Running a Linux-based single-board computer from a Windows machine can be a daunting task until you overcome a few hurdles. This walkthrough will show you exactly how to do that using a Raspberry Pi 4. Today I'll be using the Raspberry Pi 4 with 4 gigabits of RAM, and on our website, Unboxing Tomorrow, you can see the same procedure done on a Raspberry Pi 4 with 8 gigabytes done. It's essentially the same process. If you've been following this blog, then you probably know that I prefer using HDMI monitors and wireless keyboards and mice to control the Raspberry Pi 4 after it's been initialized, but it is also possible to use the Raspberry Pi and operate it completely remotely through your wireless network from a Windows or Linux machine. This is the so-called headless setup of the Raspberry Pi, given that it doesn't have a monitor to directly show you what it's doing. In this guide, I'll be discussing both setups, both with and without the monitor, so if you do have a spare HDMI monitor and a keyboard and a mouse, you can simply ignore any sections dealing with the headless setup. Before I get started, be sure to give this video a like because it really does help the channel. I should also note that given enough time, a technical walkthrough like this tends to become dated and awkward. As things change and as I receive feedback, I'll try to go back into the description and edit in any additional text that might be useful or anything that might need updating. If you encounter any type of conflict between the instructions you see and hear on this video versus the instructions that come from the official Raspberry Pi website, you should refer to the official sources first. Finally, before you get started, you should back up any information that you consider essential or valuable. And with that out of the way, our objective is to create a Raspberry Pi 4 that we can access either remotely or using a more conventional setup with a keyboard, mouse, and monitor. Besides the Raspberry Pi 4 itself, you're going to need an internet connection, the faster the better, a wireless router that you have administrator access to, meaning that you know the username and the password to it, a microSD card of 8 gigabytes or larger capacity. Very often, you'll also need a microSD card reader. To supply electrical power to the Raspberry Pi 4, you're going to need a USB-C power supply such as a charger for a smartphone. At minimum, that charger needs to be able to support 3 amps while maintaining a 5-volt output. If you're using a monitor, note that the cable that you need with this model uses the mini HDMI cable rather than the more conventional larger HDMI. Last but not least, I recommend using an anti-static wristband. At the minimum, this is to help bleed away any electrostatic charge that might damage the Raspberry Pi or its components as you're handling it. Both my wrist strap and the table are connected to my building's earth ground through a connection that I inspected myself just for safety. For software requirements, this video will focus mostly on Windows 10. You are also going to need permissions to install software such as Notepad++, which we will be installing later, as well as anti-malware software and a software tool for unzipping .zip files. Eventually, we'll also install an application called Imager.exe and another application called Putty. For now, let's start step 1 with the microSD card. Connect it to your computer and use a microSD card reader if you need to use one. By now, you should verify that the card doesn't contain any information that you can't afford to lose. This procedure will eventually erase any information already on that card, so if you have anything of vital importance, go ahead and make a copy of it off of the card. With that microSD card now readable, we need to download the official Raspberry Pi operating system and the application Imager.exe from the official website. The official URL is raspberrypi.org/downloads. On the official Raspberry Pi website, you should see a link to download the Raspberry Pi Imager for Windows. Follow that link and follow any instructions for downloading the Imager. Before you put that file to use, I recommend scanning it with your favorite anti-malware tool, which is something that I recommend for anything that you get off the internet. When that's done, go back to the downloads page and look for the Raspberry Pi operating system. This also used to go under the name Raspbian. Note that if you're not using Windows, this video probably won't really apply to your situation. In this example, I'm downloading the Raspberry Pi OS 32-bit version. As of June 2020, there's also a 64-bit version that's currently in beta, but for today I'm only downloading the 32-bit version. Now that we have the microSD card plugged in, Imager.exe downloaded, as well as the Raspberry Pi operating system, now would be a good time to unplug any devices like smartphones or mass storage devices that you don't want to have accidentally erased just in case we make a mistake coming up. Use the Windows File Explorer to locate the microSD card drive that you want to load the Raspberry Pi operating system onto. Then right-click that drive and click Format. In the window that pops up, select FAT32 and select Allocation Unit Size 32 kilobytes. I also recommend making sure that Quick Format isn't checked, although I'm not 100% sure if this makes a difference or not. Finally, double and triple check that this actually is the drive that you want to erase. If it isn't, click the Close button, but if it is, go ahead and click Start and prepare to wait for a few minutes while the drive gets erased. Once the formatting is complete, close any notification windows, and then close the formatter. Now it's time to go back to Imager.exe and the copy of Raspberry Pi OS that we downloaded as a zip file. Go ahead and use a unzipping tool to decompress the zip file. Usually Windows has this built in. After the file has been unzipped, double-click Imager.exe. This will launch the Raspberry Pi Imager application installer. If you're ready to proceed, click Install and then follow any additional on-screen instructions. When the installer is done, go ahead and run the application. You should see a screen that says Operating System, SD card, Choose OS, and Choose SD card. Go ahead and click the button that says Choose OS. In the menu that appears, scroll down to the bottom or look for the entry that says Use Custom. This is going to let us use the Raspberry Pi operating system image that we downloaded earlier. Once it's selected, you'll go back to the main screen, and now we want to click the button that says Choose SD. At this point, we should see a list of any mass storage devices that are connected to your computer. Just like before, we want to double and triple check that this is actually the drive that we want to overwrite. If it is, go ahead and select it. Back at the main menu, we should see a third button that was recently enabled, and this is the Write button. If you're ready to overwrite the card, go ahead and click Write. The Raspberry Pi Imager will take a few minutes to write to the microSD card and then verify that everything is correct. When it's complete, go ahead and close out the application. If you plan to run your Raspberry Pi with a monitor and a keyboard and a mouse, you're essentially done right now. All you have to do is eject the microSD card, insert it in the Raspberry Pi, and apply power. If you're running in headless mode, don't eject the microSD card quite yet because we need to give the microSD card a few instructions on how to connect to our wireless internet. In my case on Windows 10, Windows was a little bit weird about the drive at this point, so I could see it listed, but I couldn't see the contents. To fix this, I ejected the drive and just reinserted it, and it was visible by then. If that happens to you, you should try the same. At this point, we need to start using a text editor. The editor that I use for this video is called Notepad++. If you're using the standard Notepad that is included in pretty much every copy of Windows, this one might not quite do the job because it does use Windows-style encoding, particularly for end lines, and we need to make sure that it's not using that style, but is rather using the Linux and Unix style of inline characters. Notepad++ also makes it a lot easier to make sure that you're in Unicode UTF-8 encoding. So if you don't have Notepad++ already, go ahead and go to the website and download it. For that URL, I have a link in the description. Just like before, scan it with your favorite anti-malware tool, and then go ahead and run the application. In the Notepad++ application, we want to start with a blank document and simply name it SSH, all lowercase. you want to save that SSH file directly to the microSD card's root directory. As of June 2020, that root directory is the same directory that contains the config.txt file. With the SSH file saved, verify that it's simply called SSH with no file extension. The purpose of doing this is so that when the Raspberry Pi is powered on in a few minutes, it will see the SSH file and realize that we want to enable SSH. In the past, the Raspberry Pi would enable it by default, but this eventually became a security hazard, so now we have to use this file to basically signal what we want it to do. Back in Notepad++, we want to close the SSH file and create a brand new file. In that new file, you want to type in the code that you see on screen here. You can also find a copy of this code on my website in the URL in the description. When you're done, you want to name this file wpa_supplicant.conf. Just like before, the name should be in all lowercase letters. We should be using UTF-8 encoding, and we should use the Linux LF style of line feed. By default, Notepad++ might be set to use the Windows style of line feed, which is a CRLF, which is short for carriage return line feed. If that's the case, you want to double-click, or I believe it might be right-click, the word CRLF, and then choose the option for Unix LF. Before we close wpa_supplicant.config, we need to make a couple of changes to a few line items. In the country field, you want to type in the 2-letter code that corresponds to your country. In my case, I'm based in the United States, so this line will read country equals US. These 2-letter codes are based on the ISO 3166-1 country code, and to find the code that corresponds to your country, you can simply search Wikipedia for ISO 3166-1. The next line item we need to change is the SSID field. This is where we need to enter the name of our wireless router exactly as it appears when we connect to it. Finally, we need to enter our wireless password exactly as it appears when we log into the network. And again, you want to make sure that you also include the double quotes on both sides. Finally, double check that everything is spelled correctly, that the cases match exactly, and then save this once again to the root directory of the microSD card. This is going to wind up in the same directory as the SSH file. Now we need to figure out the IP address of our wireless router. For residential customers, this is also often called the gateway. To find out what this address is, we need to open the Windows command prompt. So press the Windows button or go to the Windows search and type in either command prompt or simply CMD. Once you have the command prompt open, type in ipconfig. This ipconfig command will give us the address of the default gateway, which is the wireless router that we want to connect to. Usually for this step, the address that we want is the shorter, simpler 4-digit format. Go ahead and write down this address or commit it to memory. At this point, we might as well eject the microSD card from the Windows computer and go ahead and install it in the Raspberry Pi. Once you have the microSD card installed, go ahead and power on the Raspberry Pi by plugging it into the USB-C power supply. For the Raspberry Pi 4, you should see a small red LED illuminate itself near the power cord. Give your Raspberry Pi a minute or two to log into the network and authenticate itself. Next, we want to go back to that Windows computer and open up a web browser. Using the default gateway address that we found earlier, enter that gateway address exactly as it appeared in the address bar. This will take you to your wireless router's configuration page. Each model of router is a little bit different, so don't expect things to look exactly like what you see here. As long as you see an area to enter your username and password, you're pretty much good to go. Log into the system and look for any type of option that lets you view the list of connected devices. In the list of devices, you want to locate anything with the host name Raspberry Pi. Here it says Raspberry Pi 2 because I had a different Raspberry Pi connected earlier and then I unplugged it. So it's probably a good idea to only do this when there's only one Raspberry Pi connected at once, just so you can tell which one you're looking at. With that, you want to write down the IPv4 address of that Raspberry Pi. Again, it's going to have that shorter, simpler 4-digit format. And like before, we either want to write it down or commit it to memory. If you don't see the Raspberry Pi listed, it could be a number of things, including a problem with the WPA supplicant file. If you think that might be the case, it does sometimes help to find another copy of WPA supplicant off the internet that is known to work for other people, just in case there's some type of problem with an invisible character or the encoding. If your wireless network uses security other than WPA or WPA2 personal, this setup might not work, and it seems like in general people tend to have a lot of trouble with WPA2 enterprise. In those cases, you might want to check with the official Raspberry Pi sources for a fix. Finally, one more thing that can cause the Raspberry Pi to not show up on this list is if it's power starved, it's just going to boot up and then reboot itself continuously. So if you have anything connected to the Raspberry Pi at this point, you should probably try and unplug it to see if that makes a difference first, and then try to find a larger power supply. Now, if your Raspberry Pi was listed, we can proceed to download the Putty application. So visit the official Putty website. Once you're there, simply click Download Putty or follow any other instructions on downloading it. Like before, you'll want to scan it with your favorite anti-malware tool. In my case, I installed the MSI installer version for Windows. So if everything looks good, go ahead and run the Putty installer. When everything is installed and you run the Putty application, you'll see a Putty configuration window. By default, there are probably 3 fields that you want to update or at least check that they're in this condition. First, you want to check that the host name or IP address field is the IP address of the Raspberry Pi. That's the address that we saw on the wireless router. Secondly, we want to make sure that SSH is selected as the connection type. And finally, we want to make sure that the port number is 22. This is probably going to be the default value. When everything looks good, go ahead and click Open to connect. Since this is the first time that we're connecting to the Raspberry Pi and it's not recognized, you'll probably see a security alert. For now, click Yes, but you might want to pay close attention if this does show up in the future. And with that, we should see another terminal appear that says simply Login As. This is a message being transmitted from the Raspberry Pi, and so we should log in as simply Pi or PI, and then when asked for a password, enter Raspberry. And both of these will be in lowercase. If you take more than a minute or two to log in, it will probably close the connection on you, but just restart Putty and do everything over again and it will accept your connection. If everything went well, you should see a welcome message. The date or the time might be incorrect at this point, but that doesn't really matter. What matters is that if we can see the Pi at Raspberry Pi prompt, that means we can use the terminal just as if we had a keyboard and a monitor connected to the Raspberry Pi itself. Finally, if you want to be able to use the graphical desktop remotely from Windows, we need to remove a couple of applications that might not even be installed on the Raspberry Pi yet, but we're going to remove them, or try to, just to make sure that we're starting from a clean slate. In that terminal, you want to type in all lowercase letters sudo apt-get remove xrdp vnc for server type vnc server. You can also visit our website in the link below and just copy that command into the terminal. Press enter, and as of June 2020, none of these applications are actually installed with Raspberry Pi OS yet, but now we know that they're not here. We know that it's going to be a clean install. So next in the terminal, type in sudo apt-get install type vnc server. Again, if you need to, you can find this in the link in the description. To install, respond with the Y key for yes if you're asked if you want to continue. When the installer is done, you'll see the prompt again, and so you'll want to type in sudo apt-get install xrdp. By default, the xrdp server will start itself immediately after you install it. With that, you can use the Windows search to search for Remote Desktop. Open the Remote Desktop application, and in the field for a computer, enter that Raspberry Pi address that we found from the wireless router. We then click the Connect button. In Windows, you'll probably see a warning telling you to verify the device that you're connecting to. If nothing seems unusual, go ahead and click OK. And if XRDP is running properly, you should see a login screen. Assuming you haven't changed the password for your Raspberry Pi yet, go ahead and enter the same username and password as before, so that's going to be PI, all in lowercase, followed by the password of Raspberry, RASPBERRY. And with that, you should now be looking at a copy of the Raspberry Pi desktop right on your Windows machine. You can click on things, you can use the terminal, and you're basically done at this point. To update your Raspberry Pi to the latest version of everything, it's probably a good idea to follow this up with a sudo apt-get update, followed by a sudo apt-get upgrade at this point. If you've run into any technical trouble at this point, check the description for this video, and I'll try to include any corrections or updates as they come up. But if you're ever in serious doubt, just be sure to check with the official sources with Raspberry Pi, XRDP, and Putty. And just for your own cybersecurity, it's probably a good idea to go back and change that default Raspberry Pi password to something a little bit more random. On a closing note, that final IP address that you saw associated with the Raspberry Pi, it can change from time to time if you go a long period of time without connecting your Raspberry Pi to the network. So in that case, you'll probably power the Raspberry Pi on and you just won't see it appear. This could be due to the DHCP lease for the Raspberry Pi address expiring on your wireless router. To avoid that sort of thing, some wireless routers do let you extend the lease time, so I've seen these leases go from like a few hours to a few months, and it will just reserve that address for your one Raspberry Pi so that you always know how to connect to it again. Alternately, you might also see an option on your router to just outright reserve the address permanently for the Raspberry Pi. But like I said, it's all pretty situational because each model of wireless router is a little bit different. So that's it for now. Be sure to leave any of your feedback, like and share this video. And if you find this sort of thing useful, things like electronics, IoT, robotics, be sure to give our Patreon page a visit. As a Patreon member, you have access to our monthly poll and our Lessons Learned series, where after technical builds like this one, I'll go back and recap some personal notes that might not justify a brand new video, but could be useful for anyone looking for in-depth insight. And with that out of the way, everybody just stay safe, stay healthy, stay curious, and as always, have a great day.